unknown concentration is combined slowly and carefully with the known volume of a standard solution until a color change shows the completion of the reaction. The substance which indicate the completion of reaction by the change in its color is called an indicator. The moment at which the indicator changes color is called the endpoint. Either solution can be taken in a butter with the either solution taken in a conical or a detraction flask. With the help of this technique, we can check the purity of the products processed in industry or are available in the market. A large number of substances are available as acid-base indicators which undergo a change in color according to the pH of the solution color change interval. The chief characteristics of these indicators is that the changes in color is not sudden but takes place within a small interval of pH termed as the color change interval. For most acid base titration, we can therefore select an indicator which shows a distinct color change of pH close to that which is obtained at the endpoint. Here is some color change of pH range of certain indicators. Phenoplastic pH range color 8.3 by 10.0. Color in acid solution colorless. Color in alkaline solution red or pink. Indicator methyl orange 3.1 by 4.4. Color in acid solution red. Color in alkaline solution pale yellow. Indicator litmus pH range color change interval 5.0 by 8.0. Color in acidic solution red. Color in alkaline solution blue. Indicator promethyl blue pH range color change interval 6 by 7.6. Color in acid solution yellow. Color in alkaline solution blue. Here is the titrant. The solution which is taken into the conical flask is called titrant or titrate. Titrant. The solution taken in the butter during titration is called titrant. Concordant reading. The butter reading which do not differ by more than 0.1 cm by 3. Mencius. The curved surface of a liquid in a narrow tube, e.g. butter or pepti, is called meniscus. Note down the reading corresponding to the lower level of the meniscus for the transparent liquid and the straight level for colored liquids. Avoid parallax error by noting down the reading at eye level. Here is some diagrams about anti-parallax card or paper. A piece of card or paper placed behind the butter and used to eliminate the error due to parallax is called an anti-parallax card paper. Upper line of saw, too high it's too low. Here brackets butter, pepper, funnel, conical flask, iron strand. Distilled water 0.1 m, HCl solution, NOAH solution. Here's the diagram about design the pepper first dissolution. So hope you will understand our second topic. We will meet in another video. Thank you. Hi team YouTube. My channel name is Chemistech. Today's our topic is about chemistry notebook. Here is my notebook. So let's restart. It's one page. Here is table of contents. We show some table of contents like chapters. In this topic we will discuss about these chapters but one by one. Chapter number 110 acids, basics and salts. Chapter 11 organic chemistry. Chapter 12 hydrocarbons. Chapter 13 Biochemistry, and Chapter 15 Environmental Chemistry. Let's start our chapter number 10 Acids, Basics, and Salt. Here, experiments identify sodium, calcium, strontium, barium, copper, and potassium ions by flame test. Here is our detail. Flame test is used to identify the presence of some material ions in a compound. It is a very quick way to identify these ions. Not all the metal ions in part color the flame. The alkali and alkaline earth metals have loosely bound vessels electrons that are capable of being excited at the temperature of the Bunsen flame. In the flame, the volatile salts evaporate and dissociate into ions. Electrons, which are plentiful in the flame, fall from outside the capsules into the valence subshells with the emission of energy in the form of visible light. The color of the emitted light is characteristics of the element. The bright orange spiritual lines of sodium in the visible regions are associated with the transactions of this outermost electron from the 3p subshell excited state back to 3s subshell. Chloride salts of metal are usually preferred for performing flames tests because these are generally more volatile than the other salts and hence easily impact the characteristics color to the flame. Spectrum of elements can also be taken when they are enclosed in the form of gas in the discharge tube. When the atom present in the gaseous state are supplied with energy, an electron is raised from a low energy level to a higher level. When the same electron drops back, energy equal to the difference between the two levels is emitted in the form of light radiations. If these radiations fall in the visible range, they can be seen as color in the form of spectrum. Here is some form of spectrum. Here E equals to Hc over. Here is electronegative atomic excitation. Here is the second atomic D excitation. Here is the Bose glass. Can you see? Blast of salt, conic HCl. Here is the flask. For more information in laboratory, nichrome wire is often used instead of expensive platinum wire. Nichrome is an alloy of Ni and Cr. It is also used in electric heaters. Here is a procedure or cautions. Here are some procedures. Take the platinum of nichrome wire and make a small loop of it. Dip it, concentrate HNO and then heat is an oxide proof flame till the wire impact no color. So our first topic is about vent. Now we will meet in another topic. I hope you will understand my all chapter. What material required? We discuss watch glass, platinum wire burners, spirit lamp, glass rod breaker. Now we will meet in another video. Today's our topic is end. Subscribe our channel Chemistech. Hi to meet you. My channel name is Chemistech. Here is the experiment 10.3. Our topic is standardize the given HCl solution volumetrically. So we will discuss first background information. Standardization of HCl solution involves the determination of its exact concentration with the help of a standard solution of NaOH. This process helps to check the purity of acid available in the market. Apparatus, pipette, button, funnel, conical flask breaker. Here is the chemicals solutions of HCl, standard solution of NaOH, phenopathic. Here is the procedure. Set up the apparatus like that used in the previous experiment 10.2. Take the given HCl solution in the butter using plastic or glass. Note down the initial reading of the butter pipe out 10 cm cube of standard NaOH solution in the conical flask. Add a drop of indicator, it would turn the solution pink. Run down the HCl solution from the butter drop by drop into the conical flask containing NaOH solution with continuously shaking. Take a rough reading like that in experiment 10.2. The end point is light pink color to colorless. Note down the final reading. Repeat the titration of accurate reading by adding the hydrochloric acid solution from the bottle rapidly to within 2 cm cube of the end point and then drop by drop till the end point is reached. Take 3 concurrent readings. Here is some cautions while sucking the solution using Pepti. Be careful that the solution should not reach the mouth. The apparatus must be approximately washed and rinsed before starting the experiment, but butter should be fixed vertically. Here is, do you know, concentrated HCl solution is highly corrosive and poisonous if ingested. It causes mucous membranes, esophagus and stomach, causing diarrhea, nausea, calculative failure and sometimes death may be occur. NaOH is a caustic, strongly alkaline compound used in the rain cleaners. NaOH, if invested, will cause vomiting, prostrating and collapse. So we will move in another page, chemical equations. Here is chemical equation: HCl plus NaOH arrow NaCl plus H2O. Here is the final reading, initial reading, and here is the calculator. Find out the molarity of HCl solution by using the following molarity equations. M1 V1 by N1 equals to M2 V2 by N2. M1 majority of acid solution, M1 volume of the acid solution, number of moles of the acid, balance chemical equation. Molarity of base solution, V2 volume of the base solution used, number of moles of the base is the balanced chemical equations. M1 equals to M2 V2 by N2 multiplied by N1 by V1. Here is the molarity of the given HCl solution is dash M. So we will discuss in this video about standardize the given HCl solution. We will meet in another video. Subscribe our channel Chemical Tech. Goodbye everyone, welcome to my YouTube channel Chemical Tech. Here is the experiment number 10.4. Determine the exact molarity of NaCO3 solution analytically. Here is the background information. Sodium carbonate formula Na2CO3 is available as washing soda, Na2CO3, 10H2O, and soda ash, Na2CO3, also called hydrosodium carbonate. The aqueous solution of sodium carbonate is alkaline in nature. In water, sodium carbonate dissociates into sodium ions and carbonate ions. The carbonate ions react with water in a reaction called hydrolysis and release hydroxide ions. Release hydroxide ions, being a strong alkali, makes the solution alkaline. Here is the formula: Na2CO3, 2Na plus CO3, CO32 plus NH2O, HCO plus O1. OH. The molarity of the given sodium carbonate solution is determined by titrating it against standard solution of hydrochloric acid using methyl orange as an indicator. The choice of the indicator is determined by the pH of the solution at the end point. In the strong acid weak base titration, the end point lies in the acidic medium. Therefore, methyl orange indicator is the best choice because it changes from orangish yellow at pH level 4.4 to red at pH 3.1. Here is a practice: Pepti, butter, funnel, conical flask, beaker. Chemical standard solution of HCl, solution of Na2CO3, methyl orange. Here is some procedure. Point 1. Resign the butter with HCl solution and calm it vertically in the butter stand. Using a funnel and small amount of hydrochloric acid solution to resign the butter. Fill the beauty with hydrochloric acid solution. Remove the funnel. Using the tap at the base of the butter, allow the acid to flow freely into a beaker to remove any air bubble present in the nozzle. Note down the initial reading. Rinse the pipette with some distilled water and then with some of the sodium carbonate solution. Design the conical flask with distilled water only. Pipped out 10 centimeter cube of the given sodium carbonate solution into the clean conical flask. Step 9 done. Add 2 and 3 drop of methyl orange indicator. The solution will turn orange, a white tile under earth. The conical flask will make the color look more vivid. Carry out rough titrant by adding hydrochloric acid solution from the butter in approximately 1 centimeter cube portion to the conical flask. Stir the flask continuously until the color of the solution in the conical flask just changes to red. Note down the final reading. Repeat the titration for accurate reading by adding the hydrochloric acid solution from the butter rapidly to within 2 centimeter cube of the end point and then drop by drop till the end point is reached. Repeat the titration until the three readings agree within 0.1 centimeter. Here is the formula: Na2CO3, 2HCl, 2NaCl, H2O, CO2. Here is the calculation and some other. So we will meet in our another video. Subscribe our channel Chemistech. Thank you.